record. All right. So today we're doing set operations, and then tomorrow we're going to be summarizing the sets. Yeah. So we begin. Okay. So to begin with, we'll look at these topics today on set operations, which is the subsets, the union set, intersection set, set difference, and the complement, the Venn diagram, and De Morgan's laws. So you have to more especially pay attention on set difference and the complement of the set. At least I know most of us know what it means when you talk about complement, but we're going to do it. I'm going to explain it in the simpler way, including this same set difference here. Yeah, some of you maybe don't even know what set difference is, but you're going to know, and you know what it means. You know how to solve questions on set difference. The Venn diagram, we know it, all of us, and then De Morgan's laws, we know that they exist, but I know some of us have forgotten. So let's see what we have for today. So we start a subset. What is a subset? So you need first, for you to answer questions on subsets, you need to know first what is a subset. So a subset is a set. Okay, for instance, here I was just on writing these definitions here, I was writing somehow as if I was writing them practically, in short. Yeah, I was making sure that they are seeming like they are examples, but at the same time, they are definitions. Yeah, for instance, here, as you can, when you read this statement, it's saying a set A is a subset of another set B if all the elements of set A are elements of set B. So for you to say that set A is a subset of set B, all the elements in set A are supposed to be part of set B. Yeah. And then, in other words, the set A is contained inside the set B. And so in other words, when you say set A is a subset of set B, we simply mean that the set A is contained in the set B. And then the symbol for subset is just this one here. Yeah, that is the symbol for the subset. Sorry, it's this one here. So whenever you see this symbol, just in mathematics, just know that we're talking about a subset. Yeah. Then, so this is an example here for the subset. You can see we have set B there, set A. Yeah. So now let's talk about the Venn diagram. What is the Venn diagram? So a Venn diagram is just a diagram representing mathematical or logical sets pictorially as circles or closed curves within an enclosing rectangle. What I'm trying to talk about, let's take examples of Venn diagrams. Yeah, let's look at this example here. So when you look at this circle here, so you can see to say this is a picture, and then within this picture we have two circles, and then these two circles, there's A and B, and as you can see, they are all labeled here. So I'm going to circulate this this thing. I'm going to circulate this this slide, and everyone is going to have it, and you all go through it on your own. Yeah. So let's proceed. A Venn diagram. I'm sure most of us know this. Yeah. Of course, I even forgot to put E here. It is always supposed to have E here to show that this is a universal set. Yeah. Some people on E they put U. There's no problem. So let us also look at the union set. What is the union set? A union set is formed by combining or by listing all the elements of all given sets. So the simple definition of a union set is here. The union set of two sets A and B is the set of elements which are in A, in B, or in both A and B. In symbols, for example, if we have A being equal to 1, 3, 5, 7, and then you also have B being equal to 1, 2, 4, 6, 7. When you find the union set there, you list all the sets of all the elements of set A and the elements of set B, you put them together. But you should note one thing here. You don't repeat one element two times when writing the union set. You can see here we have this one there. We also have another one there in set B. But when writing it here, we didn't put two ones. We only had to put one. Hence, this is the union set when you combine this set and that set. All right, so let's proceed. So let us look at the intersection set. So you guys, I know most of you know all these things. It's just a matter of revision. I'm just trying to take you back so that when we start dealing with questions on sets, you will not be confused, or maybe you will not find a point which you've forgotten. So here I'm just trying to remind you of what you did. I know you've done that. You've done this at high school, and even at the university you did them, and I know that you know them, but I know again to say you've maybe forgotten something. This is the reason why I've taken you back. Okay, so the intersection set. So the intersection set is simply formed when you look at two sets, for instance A and B, and then you get the common elements in those two sets. Those common elements are the ones that we call the intersection, or the intersection part here. And then in definition form, yeah, see, I wrote it to say the intersection of two sets is a new set that contains all of the elements that are in both sets. So in short, we're just trying to talk about common elements here. So the symbol for intersection set is this one here. You can see there. Yeah. So let us now look at these the examples. So in talk of union set, we're talking about listing. When you say A union B, we're listing A and B. So when we shade them, this is how they are going to look like. If this is a Venn diagram, then you also have your E there. Yeah, so when you talk about intersection set, we're simply talking about common elements. So when you look at A and B there, the common elements are here, where the two circles converge. All right, let us proceed. As I said, today's discussion, rather meeting, will be very brief because we're just trying to revise what we already did at high school. So we continue. Let us now talk about the complement. What is a complement? So when you talk about, maybe for instance, you've been given a set A, and then they tell you to say find A complement. A complement is simply listing the elements that are not in A, but they are in the universal set. When you list the elements that are not in A, but they are in the universal set, then you have listed A complement. Let us take a look at this definition here, which says the complement of a set A denoted by A prime is the set of all elements in a given universal set U that are not in A. So when you talk about A complement, we're simply telling you to say list everything apart from A. Yes, that is the simplest definition of A complement. Yeah, so this is how your A complement will look when you have been taught to shade. So if they tell you to shade A complement, this is how you shade it. You shade everything except A. Let's proceed. Yeah, this is another definition of this one here is B complement. We're shading everything apart from B. Okay. You can also look at this example here. You have your universal set, this one here. You also have your A there. So when you say find the A complement, you list your universal set, removing the elements of A. So what are the elements that we have in A here, in the universal set? There is 1 here, so I'll also cancel 1 there. There is 3 there, I'll remove 3 there. There is 5, I'll remove 5. So meaning the remaining numbers are the ones that we have as our A complement. We have 2, we have 4 and 6. This is what has been written here. So that's it about complement. Let us now look at something that confuses a lot of people, which is the difference of the set. Yeah, so what is set difference? So set difference is a very simple thing, something that is not even supposed to confuse you because it's the simplest. Actually, from what we have discussed, it's the simplest. So me just after teaching you this, you'll never forget. It's the simplest, I'm telling you. All right, let's proceed. So when you talk about the set difference, or rather the relative complement. So in other words, it's a complement, but it's just a special complement. Yes. Yeah, so the relative complement of the set A and B is denoted by A minus B. So this is how you write the set difference. So when you talk about A minus B, in other words, or in simple terms, whenever you find A minus B, just know to say they are simply just talking about A intersection B complement. That's so. And you know what this means? It simply means that you are listing all the elements. Um, you are listing all the elements of A, excluding those that are in B. Yeah, hope you have gotten it. Said you are listing all the elements that are in A, excluding those that are in B. So meaning you do not have to add. I mean, you also have, yeah, sorry, you do not have to add the elements that are in the intersection set. So in the set builder notation form, this is what we're trying to talk about here. She is here. Which says A minus B is just equal to X, uh, X being a member of the universal set, and then this X is also a member of A, and X is not a member of B. So in other words, it's just A intersection B complement. Okay. So the Venn diagram for the set difference of set A and B is shown below, where the shaded region represents A minus B. So this is the Venn diagram here, which shows A minus B. So like I said, when you are writing or rather listing a set difference of A and B, which is A minus B. Oh, sorry, there's already U there, so there's no need of me putting E here. There's a U here. So what I explained earlier, I said the set difference of A and B here, which is A minus B, is just list A excluding the elements that are in B. So in short, you are only going to list the elements that are in A like that. You don't have to put the intersection. Okay, let's proceed. Okay, this one is another problem to many, but it's going to be simple to you because you know it today, which is the symmetric difference of two sets. This one is represented by a triangle. Yeah, this one is represented by a triangle. Though I've never seen it to Matindi. I've never seen Matindi teaching this, but he may teach. So just for the sake of you knowing in advance, that's the reason why we are even doing this during the holiday, because I know that when you know this in advance, it will be easier for you to be writing your quizzes because you know everything before you learn them. So yeah, the symmetric difference of two sets. Here is the simple definition of this. So they say let A and B be two sets. The symmetric difference of set A and B is given by, this is the expression for the symmetric difference of two sets here. So they are saying X is such that X is a member of A minus B union B minus A, which is also equal to A union B minus A intersection B. That's so. So in other ways, if you can't know this by definition, you just have to master these formulas. That's all. Because in mathematics or physics, when they tell you to say define force, as long as you know the formula for force, F is equal to ma. If you just know this formula and then you don't know the definition of force, this is what you just have. You just give them the formula. That's all. They will give you full marks. That's the way science is. So mathematics is also a science. If you don't know the definition, just write the formula and then you solve everything correctly. All right, let's proceed. So all you need to know is the formula on this one. Let us now look at the De Morgan's law. The De Morgan's laws. As I said, today's lesson is going to be short. Yeah, because we're just going to look at these. It's actually, we're just going to be revising so that tomorrow we enter into the real thing, the sets. We'll solve a lot of questions about sets, a lot of them. Tomorrow will just be for solving. Okay? And then after solving, I'll also give you an exercise. Let's proceed. So these are the laws which were discovered by De Morgan. Yeah. So when you have A minus B union C, you can distribute, this one is called the distributive law. You can distribute this A minus to everything in the brackets there. How do you do it? You say this A minus times B, you have A minus B. This A minus, and and then this sign here, this sign here will change. So there it becomes intersection and then A minus C. So here, what I'm trying to say here, I'll show you something else. I'll show you another thing. Yeah, because I've observed something. Here we're dealing with a minus. That's the reason why you've seen this sign changing here. If there was just another sign, maybe union or intersection, this wouldn't have changed. So this A minus times that C, you have your A minus C there in the brackets. So same applies to this. You do the same. A negative here times B, you write it A minus B there, and then union A minus C. Yeah, you can see it's also straightforward. And then when you're dealing with complements here, when you have complements in the brackets, I mean you have sets in the brackets, or rather you have an operation in the brackets, and then you have a complement outside. When you open the brackets there, you discover that the sign here has to change. Whether you like it or not, you just have to change it. If you just forget to change the sign, everything becomes wrong. Same applies to this one. If there's intersection, when you open the brackets, which has the complement outside, the sign changes on the middle. These are what we call De Morgan's laws. Now let us look at other laws on sets. We'll start with okay, these are other set laws. Yeah, we'll start with these simple ones. So when we say, number one here, when we say, this U represents the universal set, by the way. And then what you need to put in mind is to say, when you're dealing with sets, you should know to say, sets also, set is also these sets are also part of mathematics. So what you need to put in mind is that whenever you're dealing with these sets, Bodmas also has to apply. Where there are brackets, start with brackets. If there is division, go to division. Yeah, Bodmas has to apply in full force. Yeah, so we proceed. Let us now look at this law here. When you have the universal set, the complement of the universal set is an empty set. How is that possible? Imagine to say you are in the room, and then we say, I want you to list uh, the number of people that are not in the room. Or rather, let me put it this way: you are on Earth here, and we have a lot of people here on Earth. We know that. Then we say, find the complement of the Earth. We say nothing. There are no people. You can never find any person as long as you are not on Earth. Earth, we know that planet Earth is the only planet that supports life. So meaning, apart from Earth, you can't find life anywhere else. So when we say Earth complement, it simply means that there is nothing. You never find any person anywhere else. Hence, it's an empty set. So this is what we mean here. If you have the universal set, you have the universal set like that. You have E, the universal set, and then you have elements there. Okay, you have elements there, and then we say this is set A, and then we say I want you to list uh, the the elements that are outside here, outside the whole set, outside the universal set. It's simply the empty set. So if the opposite is also true, the empty set complement is equal to the universal set. The complement of the empty set will also give you the universal set. Yeah, so the same applies to this one. A intersection A is equal to A. The same as telling you to say, find the common elements the common elements in A and A. You simply tell them to say the same A is common because everything that is in A are also in A. So meaning the same A is common in both sets. Hence, you get A as your answer when you find the intersection of A and A. And then when you find the intersection of A and A complement, you get the universal set. How is it possible to find the universal set after finding the complement of A and finding the intersection of A and A complement? Look at this. This is set A, This is set A, and then you have the universal set there. So if this is set A, and then you have elements 1 and 2, and then they tell you to say, and then you have, for instance, 3 this side. Then they tell you to say, find A intersection A complement. So you need to know these rules, because when proving De Morgan's laws, you need to be applying these rules. So when you've been asked to find A intersection A complement, you first have to list A. When you list A, the elements of A there, you get 1 and 2. You get 1 and 2. Yes. You get 1 and 2. Sorry, this is 2. Yeah. And then they tell you to say, list A complement. So A complement here is just nothing but 3. When you say A complement, remember what I said. A complement is simply the elements that are not in A. So A complement, the elements that are not in A but they are part of the universal set is 3. And then let us now try to see what we get when we combine the two sets there, A and A complement. What is, oh sorry, this was, sorry. This is intersection, not union. Sorry. This one is not supposed to give you empty, universal set. This one is supposed to give you an empty set. Yeah, so I'm going to correct you on this. I'm going to correct it when sending the slide. This one is supposed to give you an empty set and not the universal set. The one which gives the universal set is this one here. It's not even here. It's A. I'll put it as well. A union A complement. So A union A complement will give you the universal set. So this one is supposed to give you an empty set, because when you find the intersection set of A and A complement, you discover to say there are no common elements here, hence giving you an empty set. Okay, it's almost even time up. Let me just rush through the remaining few notes. And then A union A, you still get A. This one is straightforward. A intersection universal set, you still get the same A. Because when you find the intersection set between the universal set and A, you get A. Okay. And then A union universal set, you get the universal set. When you add A plus the universal set, because A is also part of the universal set. A is a subset of the universal set. So meaning when you find the union set of the two, you still get back to the universal set. And then A complement intersection A complement, you still get A complement. So I'm going to also add this one here, which is A union A complement, which gives you universal set. And then this one, take note, A intersection A complement is an empty set. Yeah, I'll change that immediately I finish teaching, so that when I'm sending the slide, it's going to be correct. Yeah. Let us look at the last laws. Yeah, the other laws. Okay. We have the commutative law. Yeah, so this is now mathematics. You know about associative, commutative, distributive. Yeah. Okay. So many those things, they also apply to sets. Sets are part of mathematics, and you don't expect anything to miss out. As long as all the rules of mathematics are there, they also apply to sets, because sets are also part of mathematics. So when you talk about commutative, we're simply saying whether you change the letters, whether you start with A intersection B, or whether you start with A or B, you still get the same answer. So A intersection B is just the same as B intersection A. A union B is just the same as B union A. Right. Same applies to associative. Associative simply means that if you group uh, two letters here, and then you also you also do what? You also try to group you also try to make another group here without switching the letters. You still get the same answers. Yeah, same applies here. Without switching the letters and without changing the signs, you still get the same answer. And then distributive law here simply means that when you have something like this, you can distribute it. If you remember what I said earlier, I said when you have A intersection B, when you have A intersection things in the brackets here, when you are distributing, as long as there's no minus. Remember the reason that side the sign was changing in the brackets is because here there was a minus, but in this case we don't have the minus. So here there's nothing that the sign is changing. This one is just direct what mathematics. It's just the same as telling you to say multiply A times, and then you have something like B plus C. So what you do here is you say A times B, you have A, B, and then you have your plus A times C, you get A, C. This is what is happening. Here there is times, here there is also times. What am I trying to say? This sign here, which is the intersection, is the one that is found here. In other words, it's standing in the position of times there. And then this universal set is like a plus there. In other words, it's a union there. Yeah, then when you distribute everything, this is what you get. So make sure that you go through these notes. They are straightforward. De Morgan's, I've talked about it in the previous slide. Okay. Due to time, I think I'm ending here. If you have any questions, you can inbox me. Yeah, if you have any question, you can inbox me. I'll explain further. More especially before 24 hours, I'll still be awake. All right. So thank you very much. See you in the next lecture. Please don't miss the next lecture because we're going to be solving mathematics like normal business. Yeah, we're going to solve a lot of questions on sets.